The intermediate value theorem is a tool we can use on continuous functions. First, let's learn what makes a function continuous on a certain interval. The first case is a closed interval. Our function is 2x minus 2. The bottom line here is that for a closed interval, all points on my interval must be continuous, including my endpoints, because it's a closed interval. Now let's learn how we check if those points are continuous. First, each point has to have a y value at that point that exists. Next, my function must have a limit at every x value. And lastly, those limits have to be found the usual way we're used to, where we just plug in those x values into the function. So let's look at x equals 0. As we can see, it has a y value of negative 2. We can see that as x approaches 0, our y value approaches negative 2 from both sides, so it has a limit. And lastly, to evaluate that limit, I can just plug in 0, which would be my a value, into my function, and I'll get 2 times 0 minus 2, which is negative 2. So it checks out. Now let's look at an open interval. It's exactly the same, except the endpoints don't have to be continuous. As we can see in this graph, I'm actually missing a y value at x equals 1 and at x equals negative 1. So those points aren't continuous. But because it's an open interval, the endpoints don't need to be continuous. As long as everything in between is, then the function is still continuous on that interval. So this one still checks out. Now let's get to the theorem. All the theorem says is that if I have a continuous function, and it ranges from one y value to another y value, then somewhere in between, there has to be a y value that's in between. So let's look at this function here. At x equals 1, y equals 0. At x equals 3, y equals 4. So at somewhere between x equals 1 and x equals 3, I have to have a y value between 0 and 4. This is common sense. If I have a graph that tells me my speed goes from 0 miles an hour to 60 miles an hour, at some point I had to cross through 1 mile an hour and 2 mile an hour, etc. And lastly, we can take this to the next level. If our function goes from a positive number to a negative number, and it's continuous, then we know at some point it crossed through the 0 mark. Let's use the intermediate value theorem to find the positive and negative intervals of our function. We just learned that anytime a continuous function switches from positive to negative, it must be 0 at some point. So if we find all of those zeros, then in between any two of them, our function must be either only positive or only negative. So by finding all of these zeros and testing points around them, we can figure out on what intervals my function is positive or negative. Let's look at the steps. First, make sure your function is continuous. You already know how to do that. Next, find its zeros and put them on a number line. Lastly, test the points in between the zeros and figure out what y values you get. Write the sign of those y values on the number line. Let's look at our example. Here's our function. We have 3 sets of parentheses multiplied together. First, we find the zeros. If any one of these sets of parentheses equals 0, our function is 0. So we can just find the 0 for each one. For the first set, x equals negative 1 will make that parentheses 0. Next, x equals 2 will make that set of parentheses 0. And lastly, x equals 3 will make that set 0. Now let's put them on our number line here. Alright, now let's test the points in between them. First, let's test a point to the left of negative 1. I chose negative 2. I plugged it into my function, got a positive number. Now let's find a point in between negative 1 and 2. I used the point 0 and got a positive number as well. Now let's test a point between 2 and 3. When I plugged in 2.5, my function gave me a negative number. And lastly, let's test a point greater than 3. When I plugged in 4, I got a positive number. So what does this tell us? We now know on what intervals our function is positive and negative. It's positive from negative infinity to negative 1 to 2, and 3 to infinity, and it's negative from 2 to 3. One important thing to note is that we have to use parentheses, not brackets, because at negative 1, 2, and 3, our function equals 0. It's not positive or negative, so we can't include those points in our intervals. That's why we use parentheses instead of brackets.